Hello guys, welcome back to another exciting video. So in today's video, we're going to begin a new course. We're going to be going over basically how to fine tune an LLM, right? So we're going to go ahead and understand basically what is an LLM, which is a large language models, how are they trained, how do they work, and how do we go ahead and fine tune them. So the main aim is to learn how to fine tune an LLM. But before we can do that, you're going from the ground up. So we'll understand the very basics and then move all the way up. So in this video is the first video in our course on fine-tuning LLMs. In this video, we're going to go ahead and try to understand basically what are LLMs from the very basics all the way up to LLMs. Okay, so let's get started with it. Okay, so this video, this course, I'm not going to be putting any course overview because I did it in the last course on agentic systems, and I deviated from that course or course overview because as I was doing the video, things were changing, and I wanted you guys to have the latest knowledge as much as possible. So I deviated from the initial plan, right? So in this video, I'm not going to have an initial plan because we might deviate again. So what's the approach that I'm going to be using in this course? So the approach I'm going to be using in this course is let's take things from the ground up. Let's take things from the point whereby we are not really trying to be so technical or focusing so much on the mathematics of things, but basically trying to break down things into a normal language that everyone can understand, right? A very basic language like anyone can understand, right? So even the normal Joe on the street can understand it. Anyone who is also very technical can understand it. So that's the approach I want to take throughout this course. Like, let's focus on the fundamentals rather than using a lot of jargons and complicated stuff, right? So let's focus on the fundamentals. Okay, so in this video particularly, we're going to be going over understanding the AI landscape, what's going on in the AI world. We'll look at what machine learning is, what deep learning is, what are language models, what are large language models, the different steps of training large language models, and then we'll look at something called hallucination, and then we'll talk about why hallucination is leading to us having to fine tune our models and do other different techniques that can be used to overcome hallucination, one of them being fine tuning, which is what you're mostly going to be focusing on in this course. So let's get started with it. So let's go over ahead and let's see what's going on in the AI space. Like, what's really going on? So there's all these AI buzzwords, agentic systems, LLMs, RAG systems, MCPs, and all these really funny things, A to A protocols, and all this. It's a lot of jargons being thrown around all over the place. What's really going on? Right. So go ahead and try to understand what's really going on. And but before we really understand this, I want us to really take understand the whole AI landscape. Okay, instead of just following these trends and all these jargons, right? Let's try to understand things from a very fundamental point of view. So let's look at artificial intelligence, which is the whole AI, right? So AI is just a short form of artificial or an abbreviation of artificial intelligence. So we have this abbreviation of all this whole sphere of artificial intelligence, and then within it we have machine learning. And machine learning is just basically okay. So let's take a look at what artificial intelligence is. So basically, any system that can make smart decisions. That's the way I would put it, right? So there are different definitions out there, but this is just from me. And then within artificial intelligence, we have machine learning. So machine learning basically using statistical algorithms and models and different statistical stuff, mathematical stuff, right, and programming techniques to basically train machines or train computers to be able to find patterns and make predictions based on this understanding of the patterns, right? So that's basically how I will define machine learning in my own terms. Then we have deep learning. So deep learning is all about uh they got the inspiration basically mainly from the way that our human brain works, right? So look at it more. I don't worry about that, but basically systems that process complex data more like the way humans do, right? So can do with speech, vision, and audio and all those kind of stuff, right? We'll look at this in deeper level. So within deep learning, we have neural networks, and then within neural networks, we can have LLMs. But in this case, I left out neural networks, so I just say deep learning, and then within deep learning, we have LLMs because LLMs are part of neural networks. Then neural networks can be part of deep learning, and then deep learning part of machine learning, and then machine learning part of artificial intelligence. So that's the whole. So you might see different variations of this diagram out there, but this is just the one I'm going off with. Okay, so our main focus is basically LLMs and how to fine tune these LLMs, right? So LLMs are just basically AI trained specifically to understand human language and to generate text. Okay, so let's start ahead by understand. Let's go ahead by understanding what is machine learning. So machine learning is all about using computer algorithms, different statistical techniques, and programs to find patterns and relationship between input and output data. So given X, the output should be Y. So basically, we're teaching the computer to be able to recognize these patterns, right? So given X, the output should be Y, or given Y, the output should be X. So we're training the machine, but basically training computer algorithms to recognize patterns within data and relationship between input and output data. That's basically how I would define machine learning as. So let's say that we have a house right here. So we have this beautiful house, two-story house, and we have our friend here called John. So John owns a real estate company, and he wants to build a system whereby it doesn't have to constantly tell user the prices, right? So users can go on his website, input the number of rooms they want in the house or the size of the house and other details, and then get the pricing of a predicted pricing of roughly how much such a house would cost, right? So given the descriptions of given the properties or the attributes of the house, how much might the house cost? So John wants to create a website whereby his users or his clients who come to buy real estate from him can do that. So he goes ahead and talk to Helen. So Helen is a machine learning expert, as I say, top machine learning expert, right? From Harvard or from some fancy place. So that's Helen right there. So Helen has a degree or PhD or whatever in machine learning, is just really good at machine learning. So he goes ahead and tells John, okay, for you to be able to do this, then you have to provide me with some data, and then I can use this data to train an algorithm to be able to predict house prices given the different attributes or properties of the house, right? So let's get into it. So let's say, so John goes ahead and then provides Helen with some data. So in this case, we have just two simple columns: the size of the house and the price of the house. So Helen goes ahead and use different statistical and computer science techniques or different things, and then goes ahead and builds some system which we call aka a model. So given the system is a function, this is a mathematical function, the function that takes in x as an input, and this x is a price of the size of the house, and outputs y, and y is a predicted price of the house. So it goes ahead and trains some machine learning, some fancy algorithms, and then builds a whole website around it, and then gives it back to our friend John. So basically, a user can go on the website, input the price details of the house, in this case the size of the house, and then you can go ahead and get back the output of the price of the house, right? So that's exactly what John wanted. So John is really surprised. Oh, that's really interesting. How did this go on, right? And that's where machine learning comes into play. Again, as I said, I'm going to be going over this in a very layman term, right? So I'm going to use very simple concept or very simple ways of explaining stuff to you. So if you're an expert, maybe like, that's not really it, but we just want to give the basic idea out there, right? So this is not, I don't want to go into technical stuff talking about regression models, fine tuning and finding the best fit line and all those kind of things, right? Residuals, errors. I don't want to go into all of that. I just want to explain things in a very fundamental way. So I hope now you get the whole idea of machine learning. So with some data, in this case, the price of the house and the size of the house, you can train a machine learning algorithm, or can train some algorithm to predict the house of the price given the size of the house, right? And that's where machine learning comes into play. Okay, so now we have been working with numerical data, and you're mostly focusing on LLMs. LLMs don't work with numerical data; they work with text data. So you're going to ChatGPT and you just type in anything there in natural language. So how are computers able to understand natural language? Because computers mostly work with numbers, right? Right. You're absolutely correct. So let's say, for example, let's take an example of sentiment analysis, right? So you have a bunch of, let's say again, we bring in John here. John has a bunch of reviews from his customers about his service. So John wants to predict, okay, is my service, are customers saying my service is good or bad, right? So that's actually a positive or a negative sentiment. So how do you go about building a machine learning algorithm to be able to predict whether a sentiment or customer feedback is positive or negative, given that the customer feedback is in natural language, right? Text or English, Japanese, Chinese, whatever. right? It's in natural language. So how do we move from natural language to numbers to training machine learning algorithms? So there are different ways about this. So John thought, okay, how is this possible? So there's a simple way we can do this. This is not, I'm not saying this is the exact correct answer, but I'm just using this to explain an analogy to you. So let's say I have a sentiment from a user saying, I like programming, right? So we pass this text, which is human language, into some magical box. So that magical box is going to output some numbers. So for each word is going to output an array of numbers, right? How this is done, we really don't care at the moment. So we just know that we pass in some words and then we get back a bunch of numbers. And we can use this bunch of numbers to train a machine learning algorithm that can tell us whether a sentiment is either positive or negative. So we're not really going to be focusing on how this embedding model works or how this black box works. So we just know that we input some text, we get back a bunch of array of numbers, and then we can use this array of numbers to train a machine learning algorithm which can tell us whether a sentiment is a positive or a negative. Okay, so now let's move on to deep learning. So that's basically a simple, quick introduction to machine learning. We have seen how machine learning models can work with text and how they can work with numbers. So at the current moment, at the current state of technology, deep learning is actually I would say one of the best, or actually the best machine learning approach that we have today, right? So remember that deep learning is part of machine learning, right? Okay, so deep learning is probably, as I said, is probably one of the best approaches to it by far, right? When it comes to machine learning. So one of the techniques under deep learning is the neural networks. So neural networks can handle complicated relationships and patterns. So let's imagine that right now we are passing in I love programming in a bunch. We're getting this array of numbers. In reality, this array of numbers could be really, really huge. Could be of many, many dimensions. Okay. So imagine now ChatGPT deals with a whole bunch of text. You can output a whole paragraph, right? Even write for your whole essay. So that's really doing all that, converting out each of these words into a huge array of numbers. It can be really tricky and difficult for traditional machine learning models to handle. And that's where we get these neural networks, which can handle more complicated relationships, data, and pattern recognitions, right? So with huge amounts of data, huge dimensions, we need something more powerful. And that's where deep learning comes into place with neural networks. So with this, we can process not only textual data or numeric data, but also images, videos, audios, and so on. So it can handle more significantly way bigger data sets and handle data sets in many multiple dimensions, right? So let's take a look at understanding how neural networks work. So let's take it slow. Let's back up a bit and let's try to understand how neural network works. Okay. So neural networks, as I said at the beginning, have been inspired by the way our human brain functions. So in our brain, we have this thing called neurons, and then neurons that fire together are connected together. There's a saying, something of that line, that neurons that fire together are connected together, something of that sort. I think I had something, there's a saying of that sort, right? So now each of these neurons, in deep learning we call them, or in neural networks we call them, perceptrons, right? And this is just a very, very basic explanation. I just want to understand a very, very basic concept. No terminologies, no jargons, right? So we have this thing called perceptrons. And what perceptron simply does is that they can either fire or not fire, depending on end user input, right? They can get activated or not activated. So you can take a look at the human brain, right? So you can go on YouTube, search for videos about a human brain's perceptrons, or human brain neurons firing. So you can see the way the human brain works. So some kind of like lights going in and off, right? So these are neurons firing or not firing. So depending on how neurons are fired or not fired, that controls our thoughts, right? So if two neurons fire maybe in a row, maybe your answer to a existing question will be yes. If one fires and the other doesn't fire, maybe your answer to a question will be no, right? So that's basically how we have perceptrons. The same concept, we have perceptrons in neural networks. So let me just give it a bunch of questions. So this basically a perceptron. So it can either get activated or not activated, right? Depending on a given threshold or something like that. So I don't want to go too much into the technical details of this. So let me just move on to this next slide. And this next slide, we have this question right here. So, John, again, we have John. He's selling his houses as a real estate agent. And then we have John right here. So John is like, okay, what's all these things that you guys have going on? So let's bring in Helen. So Helen comes in and explains. Okay, let's say that you have a house that you want to sell, right? This house has a lot of attributes to it. There are different factors that determine the final price of a house. Okay, so these things could be like the size of the house, the location of the house, how old the house is, the quality of the neighborhood and stuff like that, right? So all this affects the price, the final price of a house, right? So we have these things here called W1, W2, W3. So what are these? These are called weights. So let's say that the location of a house has a weight of 0.7 on its final price, right? So a weight of a house is more significantly affecting the price more than the age of the house, right? In most places. So if you want to buy a house in the city center, right? At least where I stay, if you want to buy a house in the city center, the location of the house or the fact that the house is located within the city center can make the price of the house much more expensive, regardless of how old this house is, right? City centers, they mostly have older buildings. So each each of these weights affects the final price of a house, right? So basically, we take in some numbers, multiply it by the weight, and then add all that up plus some bias, which is some random values that are initiated and then fine tune over time, right? So and then you get the final price of the house. So right, each of these factors basically determine how given attributes of the house affects the price, right? Good. Awesome. So yeah, so what how are all these weights determined and how is all this bias done? Right? That's something very complicated. Johnny might be wondering, okay, oh, we have all these weights and all these biases and all these fancy things. What's all these things? So the thing in here in the middle is called the perceptron itself, and these are the basically different inputs. These are the weights. And then we have so x1 could be here the house the size of the house x1 multiplied by the weights, right? How much that affects the price of the house. Then we do all that, right? And we add to the final bias. So how are all these weights learned and all these biases learned, right? So these are just numbers. How are these numbers, how do we come about this number? So that's where machine learning, sorry, the training of the algorithm comes into play. And with a vast amount of data, the algorithm can find the patterns of and the patterns, right? So these weights and biases help it to determine these patterns or this recognition of patterns, the weights and the biases. And this is a whole process of training a machine learning models and deep learning. I don't really want to go into that. Okay. So we can have multiple inputs, just not just the price, the size or the location of the house. You could have other things like how many bedrooms does it have, does it have a garage or not. This could be a lot of things, right? And all this could be affecting the final price of the house. So you could have multiple inputs, right? So okay, so you could have multiple inputs, and Helen explains that to John. Okay, John might be wondering, okay, but I don't think that's how ChatGPT works, right? I don't think it works like that. And it's just true. Yeah, John is correct in this case. So, moving on to things like ChatGPT and these large language models, they have way more just than just one or two layers of perceptrons or basically neurons. So right, we have input layers, we have the hidden layers, and the hidden layers are basically anything between the output and the input layer called the hidden layers. And we have a whole infrastructure around this transformer architecture and all these things, right? I'm just trying to keep it really simple for you to understand, right? So there's a whole lot of mathematics behind it, right? So it's just this is just for you to keep it for you to understand things on a surface level, right? So just for if this for a fun fact, right? ChatGPT is reported to have about 150 billion neurons, opposed to the 100 billion neurons in the human brain. So in your brain, you have about 100 billion neurons, and ChatGPT has 150, 175 billion neurons, right? So neurons are basically these things right here. So you can just see how massive this thing can get, right? So, and some models have way more than that. So it can be really crazy, right? So, yeah. So that's basically it. I just want it's a lot more complicated complicated than this, but take it at this for the meantime, and then we'll expand more on our knowledge. So, what's a large language model? So, to understand what a large language model is, we have to understand what is language modeling, right? So, language modeling is fundamentally about teaching computers to understand and predict language patterns, right? Like predicting what's the next word. So, at its core, a language model is trying to answer the question, given a sequence of words, what is most likely to come next? Right. So think about when you're using when you're on your phone, right, and you're typing out something, you're getting back suggestions, right? Suggestions. So if you type out maybe good, and then it suggests you morning, afternoon, evening, night, right? So it's suggesting to you all this based on your input. So given a sequence of words, what's the next likely word to come? I'm not saying the type correcting on your phone is a large language model. No, I'm just trying to use that to explain it to you. Because at the fundamental level, this is what large language models do. Try to predict the next word, right? So that's basically what a language modeling is basically. Just trying to understand patterns within language. One of these patterns is predicting the next word. Okay, but large language models go deeper than just predicting the next word, right? So a good language model understands grammar, context, meaning, and even cultural references. For instance, if you write the cat sat on there, right? That's the word you just write. The cat sat on there. Then the model should be able to predict. Maybe the cat sat on the mat, on the chair. It shouldn't say the cat sat on the sky or in the sky. That doesn't really make sense grammar socially, or the world around us doesn't really make sense, right? So it shouldn't say the cat sat on the elephant, right? Like that's not how things work within our society, right, or within our culture. Cats don't sit on elephants. So a good language model should understand these contextual meanings as well. Okay, and all this can be learned through providing training our language model on a huge amount of text that's basically has information about our culture and basically our environment. So basically, this requires the model to build an internal representation of language structure, word relationships, the real world knowledge, right? And like for example, a cat does not sit on an elephant. That's a real world knowledge, right? So when we scale this up, with neural network containing billions of parameters trained on vast amounts of data, books, website articles, we get what we call a large language model, right? So something like GPT-4, Claude, and other things that can help us engage in conversations, writing essays, solving problems, chatbots, customer support assistants, and a ton of other things, right? Okay, so the large in the large language model refers to the amount, like the amount of text that we use to amount of text and the amount of parameters, billions of parameters and words that these models are trained on. So amount of parameters makes them big, right? So bigger parameters, large language model, right? So that's how we come up with that whole thing of large language model. So the large just stands for how massive this thing is, how massive the training data is, how enormous the amount of parameters, weights, and biases are in these neural networks. Sometimes billions, right? 110 billions, and we've seen that ChatGPT solves 176 billion parameters. That's really crazy. Yeah, so that's basically large language models, just predicting the next word. So, in simple terms, an LLM, which is a large language model, uh, LLM is just an acronym for or a briefing for large language model. It's just more or less classic. It's just basically classifying things like trying to predict the next word by using probabilities. The only difference is that it predicts the most likely word to follow a sequence of provided words, not just that has to be done on a ton of words, right? So it has to be done for a very huge amount of words, right? So the model is trained on a vast amount of data. So you can imagine how much words this vast amount of data consists of, right? So that's done on really huge amount of text and not just your ordinary type correct on Google or within your phone, right? So that's vastly different. Okay. So where do you get all this huge amount of text from? So this huge amount of text are obtained from internet, from the books and other stuff like that. So all these are just data they pull from the internet, books, articles, Reddit posts, things like that, right? So they pull the information from different sources around the world, and they use all this to train large language models. So this basically, so we have let's imagine this kind of like neural network architecture is just our LLM. So we have a sentence right here, but this is not how they look like, right? I'm just trying to explain something to you. So the card sat on there, and then that goes in here. And then out the LLM outputs a bunch of words and their prediction. So you can say, oh, the card sat on there. Okay, we can say math. Probability for that is 4.5. We can say chair. Probability for that is 0.5. So it takes the highest probability, which is math. So the card sat on the mat. So it just predicted the next word, right? Okay. So that's basically how these things work. Always trying to predict the next word. So given the sequence of words, it basically tries to predict what's the most likely probable word to come after that. And it's all this is learned from the vast amount of data that is it has been trained on, right? So how is this even close to ChatGPT? Like this doesn't make any sense. How is this even close to ChatGPT? Well, you might be asking, like John here. John is asking, how is this close to ChatGPT? It's not even close to ChatGPT, what it does, right? Yeah, so true. And the reason is that we just repeat this iteratively. So if you go on ChatGPT and you just start typing, you can see what's coming. Like they don't come, they can come as one chunk, but you see them coming in like streaming real time, right? Word after word. So this is basically the model predicting those words. So the model predicts the word is returned to the front end. The model predicts the word is sent to the front end, or basically the website which you're seeing, or the chat interface. That's basically what you're seeing. So here we have the cat sat on the goes in here and then predicts maybe the mat. So now our new sentence is the cat sat on the mat. That can also go back into the neural network and it can predict the next word. Maybe say in goes in here, predicts again, room goes again. So that's the whole way ChatGPT can generate a whole paragraph or a whole essay or a whole letter or a whole email just by using this process. The cat sat on there goes in. Okay, mat. The cat sat on the mat goes in. Predicts in. The cat sat on the mat in goes in. The cat sat on the mat in the room goes in. So that's the way LLMs can produce a whole sentence, right? Just predicting the next word, basically giving a sequence of words. Okay, so yeah, thanks Helen for that explanation. Now let's go on to the stage of how these LLMs are trained. So we have seen how these LLMs can basically work by predicting the next word. So how are these models trained, right? Okay, so models are trained in different stages. One of the first stages is pre-training, and then instruction fine-tuning, and then reinforcement learning from human feedback, or reinforcement learning from AI feedback, or other different techniques that are used in this other stage. But with the pre-training and the instruction tuning are also applied. So let's look at some of this. So what is pre-training? So basically at the beginning stage, we are huge. So pre-training is the very beginning stage of training an LLM, right? So we go on the internet, or these companies go, OpenAI, Anthropic, they all go on the internet to collect huge amounts of data from books, articles, posting, videos, wherever they get the data from. I don't know. They get huge amounts of data, right? But I'm sure they get some of the data from the web. They get these huge amounts of data and they start training a model. Just training a model that can predict the next word, right? So during this process of training the model that can predict the next word, this model start building understanding of the language patterns, which makes them better in predicting the next word, right? So they start gaining knowledge and predicting the next word pattern, and they're also becoming more aware of the environment around them because of this large amount of data, right? So at this stage of training, the model has simply learned a lot of stuff and knowledge, but cannot really generate a useful response, right? Doesn't know, it knows a lot of stuff, but it can't generate good response. If you ask a question, it just generates something very gibberish. So for the longest time, people thought LLMs were not really useful because the pre-trained models weren't generating anything useful. And then came other techniques, right? So we have talked about this already. So if you ask a question, a pre-trained model can just output some gibberish, right? So Yeah, so if this is the case that LLMs are also always generating some pre-trained model, sorry, are always generating some gibberish, then like why are we using them and why doesn't ChatGPT generate always gibberish stuff, right? So that's where the next step comes in the pre-training process, whereby basically we train a model more on how to get better and how to generate a response even in a better approach. So let's go over this stage and let me explain to you right here. So instruction fine-tuning. So what is instruction fine-tuning? So basically now you have trained a pre-trained model. It has a general understanding of different language patterns and understanding of the world around it, right? So good. So once that he has this knowledge of understanding the world around it and predicting the next word token, so and then if I ask the question, it generates a bunch of gibberish stuff. So how do I take this model that has language understanding and a bit of knowledge about the world, use the vast amount of data that it has been trained on, and make it useful, make it into a chat GPT I can use, right? And that has been a question for some time, right? So what basically, and then instruction fine tuning came into in the picture. So basically instruction fine tuning is just taking this pre-trained model that generate a bunch of gibberish and turning it into a model or an LLM, basically a machine learning model that can answer questions in a desired and expected humanly way. So if I ask the question, it should answer me using the knowledge it's gained from pre-training and its understanding of language patterns to be able to provide me with a sensible answer that's actually right in a humanly desired manner. So how is that done? Right. So this is where we take a bunch of questions. So we have data set of question and expected response. Question, expected response. So we train the machine. We take these pre-trained models and train them again, saying, "Hey, if I ask you a question like this is how I want you to respond. If I ask you this question, this is how I want you to respond." So we generate a data set like this of thousands, and millions of rows, right? And we start training these models, pre-trained models again. So given this question, this is how I want you to respond. Given this question, this is how I want you to respond. So this data set is generated by humans, right? So, and then it's trained upon. So we have this thing called supervised. That's why the whole term of supervised fine tuning, or SFT, or some people also say supervised instruction fine tuning. Basically, teaching the models to follow instructions and to answer questions in a way that is humanly desired and not just in any gibberish way that pre-trained models do sometimes, right? So question, this is how you answer. Question, this is how you answer. Question, this is how you answer. Basically, the pre-trained model learns how to take in a question and generate a useful answer that's humanly desired. So that's basically how supervised fine tuning comes in, and then that's how instruction fine tuning comes in. Right. So if you go ahead on Hugging Face or out there and you see a model that is saying basically instruction tuned, this is what basically it does. So it is trained, it is take a pre-trained model and train it to answer questions in a certain way. Right. Okay. So let's say that you have a company and you are trying to build some infrastructure with some chatbot for a company. You can, if you have the money, you can generate your own data set and fine tune a pre-trained model, which you can get from Hugging Face or other sources. Okay, so now, okay, we have these models that have gained knowledge through pre-training, and now we have instructed them to answer questions in a way that we desired. Okay, awesome. Now that we have all this done, we know that we train this pre-trained model on data from the internet, right? A huge amount of data. And nobody sits down and read through this data, like curates this data line by line or sentence by sentence or word by word. So this data, like if you know, if you're on the internet for a while, the internet can have some horrible stuff, right? So violent languages and other things that you don't want to be included within your model. So if you go on ChatGPT and you try to make it, maybe ask it to basically teach you how to hack into a system, right? It's not going to do that. It's going to tell you, I can't provide you the answer to that. But the pre-trained model that ChatGPT was built on learn things from the internet, right? So it should be able to tell you how maybe to hack into someone's computer because that information is probably somewhere on the internet, right? But it doesn't answer such question. So how is that achieved? How is that behavior achieved? Because instruction fine tune it only uh, basically teaches the model how to follow instructions and how to answer questions in a human desired way. So this is where reinforcement learning from human feedback comes in. So basically, we have humans who go ahead and help to train this model, saying, hey, you shouldn't do this, you can do this. Basically, train a model, basically, train a fine tuned model or instruction tuned model to follow human patterns, right? To follow human values, preferences, right? And avoid things that we don't need. Like, for example, if you go on ChatGPT and ask it how to hack a system, it's not going to tell you the answer because it has been trained on what are good human values and what are bad human values, right? Again, I know some people are out there finding jailbreaking the systems, yeah, and that's what's actually possible as well, right? Because they have this information within their core. We just have to find a way to extract this information and bypass this reinforcement learning thing, right? Okay, I'm not here to spread that information out, but I'm just giving you the knowledge, right? So that's basically it. So fine tuning, reinforcement learning from human feedback, just basically train these models or basically to follow human values and preferences. Like you don't want to have a chatbot that can tell someone on how to kill the other one. We don't want that, right? So yeah, so that's where you can use reinforcement learning from human feedback. We also have other techniques you can use, such as reinforcement learning from AI feedback, because having human do this all the time, generate data to do this reinforcement learning from human feedback, is time consuming and it's not really scalable and can stand the growth of AI development. So other people suggested they also use AI to generate. Now that we have good AIs, right, we can use those AIs to generate data set that we can use to fine tune these new coming models. Okay, that's also one technique. But at the very beginning, there was no AI to generate the data set. So we have reinforcement learning from human feedback. Okay, but now there are also other techniques as well. So this is just three of these stages, but the other stages that other companies use, right? So there are different things out there. I'm just giving you the setting the ground. Okay. Okay. Now let's look at what hallucination is. So if you've been following this video and you've been paying attention, you know that the whole time we never focused on teaching these LLMs to say the truth. We're just basically focusing on, okay, we want you to predict the next word. We want you to gain knowledge about how the world works, understand language structures. That's all we have been focusing on. Not even once had we mentioned about how do we make sure that these LLMs are telling truth. We never mentioned that. So LLMs have not been, this behavior of LLMs telling the truth have not been baked into the LLMs from the core. So what has been baked into LLMs from the core is always trying to predict something, always predicting something. Like no matter what, they will always predict something, right? So even if the accuracy or the probability of that prediction is 0.0001 and it's still the highest, then it's gonna output that, right? Yeah. So that's basically how now if that's the case, then how are AI systems able to say the truth and stay away from lying? Because sometimes you might ask ChatGPT something and it gives you some answer and you're like, no, this is wrong, right? And unfortunately, this happens a lot of times. So this is what we call LLM hallucination, because they're always trained to predict something. So if they're going to predict something anyway, regardless of it being truth or false, because we never taught them how to really put out true content. So they're always being trained on, let's output something. Anything we output, just output something, right? So we ask a question that doesn't know, it's going to output something. Always outputting something, right? So that's where hallucination comes into play. So how do you go about beating hallucination and making sure that AI systems are providing us truthful, relevant, and accurate information, right? How do you go about and try to achieve that? And that will be covering that in the next video, right? We'll look at how different techniques have been introduced to try to reduce LLM hallucinations and get them to focus on saying truth content, right? Yeah, guys, that's all for this video. This is the first video in the course of fine tuning. So we have learned the basics of LLMs, how they work, why we need to fine tune sometimes, and how to build hallucinations and all this AI pool of AI knowledge. Yeah, so that's all I wanted to cover in this video. Thank you guys so much for watching, and if you find this video helpful, One of the easiest way you can support the channel is just by liking this video, dropping a comment section below. Let me know how you find this content, right? If I should make such videos, more of such videos or other stuff like that, you can let me know in the comment section below. And if you want to connect with me, you can connect with me on LinkedIn at Code with Prince, or sorry, on YouTube at Code with Prince. On Medium, I also have articles about this video. So if you want to follow about, if you like reading, if you prefer reading to watching videos, I have a whole written article on Medium. You can also follow me. The link to this article is going to be in the description of the video. So follow me on LinkedIn as well to stay updated as well. On LinkedIn you can find me at Code with Prince. So let's go to Medium. Sorry, on Medium you can find me at Code with Prince. So let's go to on Medium you can find me at Prince Grandpa. My bad. So go to Medium and then search for Prince Grandpa. You'll find me. On YouTube you can find me with Code with Prince, and on X you can find me at Prince_Grandpa. And on LinkedIn, if you have any questions, any suggestions on how future videos, anything you want us to work on, you can find it, or you can reach out to me on LinkedIn at Prince Grandpa. So LinkedIn at Prince Grandpa, you'll find me. If you have, a much faster to respond to you on LinkedIn. So let me know in the comment section below how you found the video, or you can follow me on these other social media platforms. If you like reading, you can also find the article about this video, which is much in depth, right? A bit much in depth, right? So guys, thank you so much for watching, and have a good day. See you in the next video, and keep safe. Goodbye.